in this video we will demonstrate how to connect Delphi to 3 units, Mark III microcontrollers, 2 Arduino Unos, and 1 Wemos D1 Mini. As you can see on the table here, I have the Wemos D1 Mini here, connected to an LED. And I have a Arduino Uno here with an external Wi-Fi module, and I have a second Arduino with also a Wi-Fi module connected externally. And in the end of the program, we will be able to use some buttons, some toggle switches, and we can activate an LED on this card and also loop it back so we can get it back as the LED on the screen shows. The next one, we have an LED down on this card. It's easy to see, but there's also a loop so we can see that the interface is working both ways. And on the Wemos we have a blue LED that we control. We will use Wi-Fi connection to test all this. So this is what we want to build up today by programming all the units and such. So I hope you enjoy watching. Thank you. So for this project, we need to add some components to our Delphi, and I want 3 LEDs, so I'm adding those. This will come from each of the unit. 1 Arduino, 2 Arduino, and the Wemos. For the opposite way of communication, I will use 3 switches. I will use a toggle switch. Now for the communication, we need to add a socket component. We configure these 3. So on the Arduino One, I will use the one IP address. And I set the port to 8080. For the Arduino 2, the second one, I will set 101 in the IP. For the port here, I will use 8181. For the third Arduino, or it will be the Wemos D1 Mini. And for the port, I will use 8282. Double check it's correct. So if we click down on the open wire, we will see that we have some components from the Mitov software. So I will place them a little bit nicely here. On each of the client socket, we need to have a packet component and an unpacket component. So we go back to the design. We can search for the packet. We need 3 unpacket. If we go down from the design to the open wire again, we can see that we have the packet unpacket. So for the things coming out of the client socket, we need to unpack it. For the things we want to send into the client socket, we need a packet. In the packet, all the packets, we need to use head marker or some bytes to not interfere with the data stream that is there. And also the synchronization will be good in the data transmission. So for this, we enters the bytes for each of these. In this example, I will use 55. You can use any number as long as it does not exist in the data we are going to send. Just confirming that it's correct. The data we are going to transmit out to the LED on this design area. We're going to send from the Arduinos. So in the open wire, we can we need to look at the packet or unpacket. I think we can do from here in the open wire. So here in the packet one, we can double click and we select one boolean. You can double click here, or you can add it up here also. So we do that for the same for the two others. Here we can just connect the wires. And we can connect from the client socket into the unpacket. Here we can make the connection from the packet, the things we want to send from the Delphi over to the Arduino or the Wemos. And here the same way in the packet, we want to have some inputs. So we select a boolean for this one. Same for the other two. And as you can see in our design, we have these three toggle switches, which is not a part of the open wire. So for making this connection into the open wire, I will add a source component. If we look at in the open wire, again, you can see that we have three elements, components from the Mitov software. So we can just drag them in place. And we can connect the the wires. With these components, we can actually send in from the Delphi true or false value. We can write to this one, like here, it's a LL source 3, and it has a value. And if we change this in the Delphi program, various combinations, this output will be true or false, and this we can send in. So the next we need to do here, we need to, if we look at this this sourcing, we need to write to this value when we using these toggle buttons. So for this, to make it a little bit short, I will use a timer here in many ways to do this. So we add one timer, and we open the timer, double click it, and here this will happen once a second, and I will type a code here. So if, and I can show you this right away. If you look at the design here, you click one of the toggle button, and you can see the name for this toggle switch. You have toggle switch 1, and if you scroll down to state, this is the state. You can see the state is either TSS on or TSS off. Now we can easily test it. If I click it, you will see it changes the state, and this is the state we will use. We can use by clicking the button, and then we write this command, but I will use a timer in this case. Because if I'm using the keyboard and such things, I will not click with the mouse, and so that's why I will use only one component, and that's the timer. So we set this back to TSS off. That means toggle switch off. Yeah. So in the code again, we have the code here. Now using a if, and I insert toggle switch 1 dot, and we have the state, and we checking if this is true. Then we want the LL source 1 and value as shown before. Should be equal to true, else LL source 1 value should be equal to false. And you saw now that this state cannot be true or false. This state need to be TSS on, and no errors on the line. So we end this one, and this one, when he sets this to either true or false, depending on the state of the switch, we will activate. You can look in the open wire, and we can see that we changes this from true to false. This means we get a signal in here. So the easy thing now we can just copy this line, and we can just go in and set the numbers for the other one. When this is done, I think our program in the Delphi is complete. So now the next we will do, we will open Visuino. I will open, can take away this one, And I already pre-made some empty projects for them. So in this case, we can start with the first Wi-Fi module. And here we will need to connect it to a Wi-Fi network. So this is the ESP826601 module. The small Wi-Fi module. I have a previously video on how to program it. So first now we will just make the programs for all the units, and then I will upload the programs to them, and we will check its functionality. For this unit, we will have to go to the modules, open the Wi-Fi, and as you see here, we have to connect to the access point. Here it can be set up as a module as an access point. So, but we want to connect to an access point we already have. So we expand this one, we click this here, we're adding an access point. And we go into the configuration. And I set some static value on my choice. And now this is the router. We need to specify the host, the SSID for the router. And we need to insert the password for the router. All these settings is complete now. Can be closed. We can select this unit again, go down to modules, Wi-Fi, and we can select the host name as well. We now have the insert the values for the Wi-Fi, so it will connect. One thing we can do when it's connected to a Wi-Fi network, we can pull a wire from the remote connected, and we can go down to the LED, which is GPIO 2. So we can see it. Now we need to add the first our first socket, only socket on this card actually. Adding a TCP IP server. Setting the port to 8080. And you now can see that we have a TCP IP server socket, port 8080. We have an input here, and we have an output here. Here we need to add the two components. one packet for the input of the socket, one unpacket for the output of the socket, we will add some head marker. We insert the same bytes as we have in our Delphi project. We double click the packet. We go down and we select a digital element. We open the unpacket and we select a digital element for this one. Now this will receive and send data to the Delphi project, and we want to have this data sent from the Wi-Fi module and over to our Arduino. So for this we will use the serial port, and here we will do this exactly the same. We will add a packet for what's going in. We will use an unpacket for what's going out. We easily connect the wires. Since this is a different interface, I will use the same head marker bytes. We will add some elements here. We add the digital. Coming from the Delphi, connected to the socket, the digital out in this place. We easily connect with a wire down to the packet here on digital in. And the same way from the data we want to sending from the Arduino coming out here, we connect this digital out, this digital in. Now we save the project. We will later transfer it. We can open the Arduino one. Here the data will come in and go out from the serial port. So here we need to add a packet. And we will add an output unpacket. We connect the packet out. To the serial in. And the serial out to the input of the unpacket. Doing the same thing, adding a head marker. We'll enter the packet, adding a digital. Then for unpacket. For this demonstration, we take the digital out and we want to display it on the LED, inbuilt LED on the Arduino, which is pin 13. And for this digital pin 2, I will use this input pin, and I will put it into the digital in here. This means that if I send something in on the digital pin 2, I can receive it here. And in this case, I don't have any external pull-up resistors. So we need to do is go in to click the Arduino Uno here, and we go into the digital signals and expand this one, and we will say that this is a pull-up. This means that it will be high all the time until we ground this pin. It will go low. Now our first Arduino and Wi-Fi module is complete. We save the project and we do the same. We open Wi-Fi module 2. Here we will set up the same thing as we did before on the Wi-Fi module number 1. We open the modules, open the Wi-Fi, connect to access point, clicking the 3 dots here, adding a Wi-Fi access point connection. Into the config, I set in the values. Using the 101 on the end here. Access point name. What's this one? Going in to the Wi-Fi again and the modules. Setting the host name. Arduino 2 in this case. Using the bit for the remote connected and adding it to the inbuilt LED. I'm adding a socket, TCP IP server. I will select the port 8181. Adding a packet to the socket. Adding an unpacket to the other part of the socket. Connecting the wires. Adding head marker. Adding one digital element. This is on the Wi-Fi module. We now need to transfer and receive from the serial port going to the Arduino. We'll add one unpacket. Adding one packet. Adding the head marker bytes. Adding one digital here. Adding one digital on the other packet. And connecting the unpacket one to the packet of the COM port. And connecting the out unpacket the COM port to input of the packet of the socket. It can be worth to mention that if you don't want to send the data so fast, we can insert a timer here. So we can add that. I think we can test without, to not have any delay when we clicking. So we will test that first. If we need it, we will sooner add it. We connect the last wires. So if you have using this on your regular network at home, it can be wise to add a pulse generator connected to the packet here. But for now, I want the connection to be fast. I want it to happen at a very quick rate. So I will not do this this example. Now our project looks complete. We will save it. And we will open the Arduino 2. Here we need to add a packet. One unpacket. Connecting the wires. And we go down to the head marker. It's a packet ID, 5555. adding a digital element or packet, adding a digital for the unpacket, connecting the digital out to pin 13, digital out 13, which is the LED. Adding the output digital 2 to this packet, and we're adding a pull-up resistor, which I don't have externally. Now Arduino 2 is ready, and we save this file. And now for the third unit, we will use a Wemos D1 mini. It has integrated Wi-Fi on it, so it makes it more easy than soldering it. So it's advisable if you're going to do this and you don't like the soldering and connection thing and all this kind of thing, you should stay with the modules that has inbuilt Wi-Fi. It makes everything more simple. But for this case, it can be good with a Wi-Fi module, external Wi-Fi modules, if you have a bunch of old Arduino Unos or such that you want to make Wi-Fi accessible on. So it will be this will be a good combination. We select the correct board, going down to the modules, into the Wi-Fi, open the connect to the access point, selecting a Wi-Fi access point, setting our configuration to the router, .02. I will use 102 as in our Delphi project. Setting in the router name, Wi-Fi router name, SSID. Adding the password. Taking one wire from the remote connected. Down to the built-in LED. Now we will need to add a socket. So we go into the modules, into the Wi-Fi. We can add the host name. Open up the sockets here. TCP/IP server. Changing the ports to 8282. adding a packet, adding a unpacket, connecting the wires, adding a head marker, adding a digital element, adding a digital element, on this project I will use digital 1 as output, shall have a LED connected, and for as input of the Wemos and sending out, we will take that packet in here and we will add it to the digital 0. I noticed something recently. I wanted to use a digital pull-up inside the program, but it didn't work. So in this case I needed to add an external one, but just for showing we can use this as a pull-up, but it didn't quite work. So I will add an external resistor for this project and the button. We will save the project, and all our project is saved and complete, and we are now ready to upload the programs to the different units. So now we will upload the programs to the different parts. So I will add the camera here, and as we now are in the Wemos D1 program, we have already connected it to program. We can take out the power again. So this is the Wemos here. Oh yeah, I put some tape so it does slide down from the table, and we can now transfer the program. writing now. And as you can see, the blue LED was leading up a little bit while it was not connected. Then it shuts down when it's connected to the Wi-Fi. So for the next program, we start with we open up the program and we take the first Wi-Fi module. That means this unit over here connected with wires to the Wi-Fi module. So we're going to program this small card here now. So for doing this, we have opened up the program. We can check once more. I think I forgot before to add the in the config. I can expand this a bit now. I think it's okay. So this is all good. We need to set this Arduino Uno into a reset, so it will not interfere with this cable. Now we have to check the swapping of this cable. So it's important to mention that if you're going to interface with the Wi-Fi module down to the Arduino, the TX need to go to RX and the RX need to go to TX on the car. So as I see it now, the TX goes to the TX here, and that means TX to TX and RX to RX. It means that the programmer on the Arduino Uno can program this car. When we later need to interface normally with it, we need to swap the TX and the RX cables. I will show you that soon. For putting this Wi-Fi module into programming mode, we will need to take the reset pin, then a GPIO 0 pin, which is the white cable in this case, and we will ground it. We'll do that here. In my previous video, I toggling the reset pin that I found out that it's more easy to just take the power on the board instead. So we will do that. By connecting the USB to my laptop. The Uno is just set in reset, so we're only using the inbuilt programmer here to interface with the Wi-Fi module. We're selecting the correct COM port. Program is ready, and we start transferring the program. As you can see with the ESP modules, it takes some time. It takes some time to start, and also programming. Now it's writing the program. You can also see the blue LED on the Wi-Fi module that it's blinking. It's not so easy to see, but if you do it yourself, you will see it. When this is a success, disconnect the power, remove the GPIO 0 pin from the ground. We need to swap the TX and the RX cable. And we remove the reset pin. We open up the Arduino One program. And we're going to write the program, selecting the COM port. We have to plug it in first. You can see on the Wi-Fi unit it's blue and it shuts down, so that means it connected properly to our access point on the floor here. We're selecting the COM port. And when we going to transfer to the Arduino Uno, it will use this TX and RX pin to program this chip. So just when we start the transfer, we will release these two pins. You have some time after you click the compile and upload. You have some time to remove them. And shortly after it's a success, so you can plug it in again. So in this case, you can start with the Arduino 2. And we will start with the Wi-Fi module, which I have put down here. I put some tape so it will not slide away. This unit has a breadboard actually from before. For doing this, we need to use that jumper for programming in the Wi-Fi module. We need to use that jumper to reset this chip, because we're going to program the Wi-Fi module via the inbuilt programmer of the Uno. And we need to ground the GPIO pin. And we will insert it into the USB of the computer. We open up the Wi-Fi module number 2. We're selecting the correct COM port. And we transfer the program. And can be worth to say that if you don't want to have all these wires and programming each Wi-Fi module separately like I do now, you can go for a Arduino with a inbuilt Wi-Fi on a lot of other cards. So that has this inbuilt already. and you don't need to program 2 steps. Everything is on the same board. Now it's writing to the Wi-Fi module. This was a success also, so we released the wire. We remove the GPIO 0 pin from ground. We have to swap the TX and the RX pin for letting the Uno be able to talk to the Wi-Fi module. We release the reset pin. We will open the program, Arduino 2 in this case. It will be the same COM port as you. Connect the power. And the blue lid is lit up here. And then it shuts down, so we know for sure that it's connected to the access point. Now we will transfer this program. So press compile and upload. I'm removing the TX and the RX pin a little bit to the Wi-Fi module. And this was also a success. You can set in the pin again. Now all the programming is done of all the 3 units. So back in the Delphi program, we will now test the functionality. I have a power bank over here. So I connect the Wemos and it shows that it's connected to the access point. The access point is down here, by the way, on the ground. We connect the other Arduino. It shows a blue LED for connecting to the Wi-Fi. And we connect the last one. And the connections here now. And it shows connecting. Yeah. Now it's connected. Everything has power. And we are about to test. You can see the Wi-Fi point. You see the LEDs down here that it's not blinking yet. And we will compile and run the program in Delphi. As soon as we do that, we see that the LEDs on the Wi-Fi router is blinking. That means that there is some kind of connection. I also, before this video, last sequence, I connected a LED to half side of this breadboard. So I have made a connection out from the Wemos. So when we started this program, it ended up on the opposite screen. We'll move this down here so you can see it. We're now ready to test the first one. I also made some connections from the pin 13, which is our LED. Moved it over to the input of the pin 2. Testing the first button. You can see the LED on the Arduino, it goes on and off. And shows us the LED. So I know that I have a loop. If I remove that pin, only connected to the pin 2, if I ground it, this goes off. If I put it to 5 volt, it goes on. Back to ground again, it's off. So it's very important that this digital input pin is connected to either 5 volt or 0 volt. So otherwise they become very unstable and can blink and such. So, but it's working anyway. So I use this pin as the pin 13 on the card, which is the LED. And that means when I activate the LED on the card, I receive the same signal. It goes all the way in the loop. I did the same for the second Arduino. I have a loop cable here. Goes from the digital input 2 to the output 13. And when I activate it, I see that the communication is working all the way around. And the same for the last one. I also have an LED, as I told you. And we can see that the two-way communication with 3 units microcontrollers connected in Delphi. So yeah, this is good. I'm happy with this experiment, and I will use this in my home automation lab, which I will develop, where I will connect more stuff in the home and using more variables with the timers for activating on and off. And I will use Delphi for doing that, and also Visuino. So yeah, I'm quite happy with this first experiment of connecting 3 different units with the Delphi and with external Wi-Fi modules, and also a Wemos, which is very easy to connect, requires no soldering. So I'm very happy with this. So if you like this program, don't forget to like and subscribe. I hope this will be useful for you to give you a quick start on how to use the Delphi from Embarcadero and the Visuino from Mitov Software. I hope this is a good sponsoring video also for the Visuino and the Delphi, which I mean thinks is very good programs for doing this. I like them very much, and they are very useful. So have a nice day, everybody. Thank you. Bye. Thanks for watching. Bye bye.